The McNemar test is similar to various chi-square tests in that the data associated with such is typically first structured within a contingency table. However, certain unique differentiations do separate the two. Those being, the McNemar test can only have 2 rows and 2 columns within a corresponding casualty table. The McNemar test is primarily utilized for analyzing drug trial results. And the McNemar test is applied in instances where a surveyed individual is represented by 2 values, thus creating non-random samples. And the third point is probably the most important to understand. And within the video description, along with the associated code, there's a link to a Stack Exchange thread that goes over in greater detail some of the differences between the McNemar test and the chi-square test. Now, if you're within a statistics course right now watching this video, you'll probably experience the McNemar test in examples as it relates to drug trials, because that's where you typically see the McNemar test deployed. So let's go through a drug trial example ourselves. In our fictitious drug trial example, individuals are gathered from a select demographic which is particularly susceptible to heart disease. These individuals may either be already afflicted with heart disease or at a high risk of developing heart disease in the future. A new drug has been synthesized which has been created to prevent the onset of heart disease. The drug is provided to individuals within the demographic, and the health outcomes of those individuals are monitored and recorded. The data is organized in the following contingency table. So I'll explain what each row category and cell category is demonstrating in the subsequent slide. But first, I want to show you how to create this matrix within R, because you'll need to create the matrix first before you can apply the McNemar test within R. So we're going to create a matrix, and the name of that matrix is going to be named medication. So we need to go from top to bottom, left to right, define each matrix cell. So we're going to say 75 is our first cell, then 55, then 22, and then 44. We have 2 rows. Dimension names equal affliction, those being heart disease present and heart disease absent. And then for our rows, drug trial, we have after drug trial present and after drug trial absent. If we're to run the name of our matrix, medication, we should see the following output in our R console. You can modify the code in the video description to suit your needs for whatever the example may be that you're working with. So this is what is being demonstrated or displayed within each cell within the matrix. Those with heart disease prior to the trial who still were afflicted after the trial, 75. Those with heart disease prior to the trial who were afflicted with heart disease after the trial is 55. Those with heart disease prior to the trial who did not have heart disease after the trial is 22. And those without heart disease prior to the trial who still were unafflicted after the trial is 44. If we're to sum up all the cells, that gives us the total number of participants who participated in this trial. So let's go ahead and apply the McNemar test. So in R, it's McNemar.test. This is the function, and this is the name of the matrix, medication. So if we apply this particular function to this matrix, this is our output. Here is our McNemar chi-square value, our degrees of freedom, and our associated p-value. And because our p-value is less than our assumed alpha value of 0.05, we will reject the null hypothesis. But first, let's talk about the hypothesis structure. So here is how the hypothesis is structured symbolically. But as far as to how that translates into the actual hypothesis written out itself, is there is no difference in the proportion of the 2 outcomes between the paired groups. That's our null hypothesis. And the alternative hypothesis is there is a difference in the proportions of the 2 outcomes between the paired groups. Because our p-value was less than our alpha value of 0.05, we reject the null hypothesis, and we would state that there is a difference in the proportion of the two outcomes between the paired groups. So therefore, we would state our findings in APA format. A McNemar test was performed to assess for differentiation in the outcomes of heart disease, present and absent, between the paired groups of the drug trial, present and absent. There is found to be a significant difference in the proportions of the two outcomes between the paired groups at the p less than 0.05 level. McNemar's chi-square is 1 because that's our degrees of freedom. N equals 196 because that was the total number of our drug trial participants. 13.30 is our McNemar chi-square value, and p is less than 0.01 because our output for our p-value was less than 0.01. So that is it for this particular lecture. Thank you for tuning in. If you haven't already, please consider liking and subscribing. Best of luck to you with your research, and take care.